Good afternoon, everyone. So my name is Samrith, and today I'm going to be talking about React Native, and more importantly, we'll be talking about how it works at scale, and we'll dive deep into like how React Native works under the hood, because a lot of people that I've spoken to have a lot of questions about it, and so yeah, we'll be looking at that, and also how we at Dream 11 use React Native to power our app. First of all, I want to know how many of you here who are here have heard of React Native? Perfect. How many of you have used React Native? Cool. And how many of you would like to use React Native? Awesome. So cool. What we'll kind of be looking at is initially we'll go through how React Native works under the hood. Well, one of the most obvious and like, the biggest benefit of React Native is that it's cross-platform, right? And with the recent investment in React Native from all the partners in the community itself, as of right now, React Native works across Android, iOS, Windows, and the web. So yeah, which is really, really great. Um, and the other question that I generally get is it truly native? The short answer is yes. The long answer, it's a little bit more complicated, right? In native, the way that we write apps is that you interface directly with the renderer, right? So for example, for Android, you might use Java, Kotlin, and on iOS, you might use Swift, Objective-C, whatever. In React Native, you interface with the native renderers via JavaScript, right? So essentially what you're doing is all of your user interactions, navigations, all of those things are written in JavaScript, and all of your views and all are written using React. And these are commands that are issued to the native layer, and that can essentially kind of draw those views for you, right? The UI rendered on the screen is still native. So for example, on Android, it uses like view and text and stuff. And on iOS, it uses UI, text, view, and whatever the native components are, right? So essentially, the way that it works right now is that whatever instructions that you write or whatever code that you write in JavaScript, right, that's serialized, sent over something called a bridge. So the bridge is a communication layer between JavaScript and the native world, because obviously native can't understand JavaScript because it's a completely different language, different paradigms. So the way that we do it is the bridge is like the interoperability layer between JavaScript and native. And all of your instructions are serialized JSON, which are sent over the bridge to native. Native receives this message, deserializes it, and essentially executes those commands, which is maybe showing some animation, rendering some text, some view on the screen, right? So yeah, now with this was the case until 0.73 version of React Native. From 0.73, the React Native team introduced bridgeless mode. So bridgeless mode essentially is like cutting off the bridge, right? So no more bridge. You can essentially, if you're on 0.73 and above, you can opt into it. From 0.76, this is the standard, right? So the way that it works in bridgeless mode is that JavaScript can now directly interface with native via host C++ objects. I won't get into details of that. But there's a very good article on it on the React Native website. So now essentially there's no serialization, deserialization. You can actually send your instructions directly to native, which is really, really fast. And yeah, there's lesser overhead even when, for example, your app is starting, because it needs to initialize lesser things, and the cost of initializing the bridge is also pretty high. Cool. The next thing that we'll kind of look at is the mobile phone landscape in India, right? Why it's important is because when you're developing an app for the Indian market presents a lot of unique challenges, right? React Native is great. Like you essentially write once, ship it to both Android and iOS. But with the Indian mobile phone landscape, some things get a bit tricky. So essentially, to give you a gist of the landscape, the average cost of a smartphone is around 14,000 rupees, right? This is roughly around 200 to 220 odd dollars. Android, like no surprise there, has 95.73% market share, right? And also, as of September 2023, India has 1.05 billion internet users. This is primarily because India is the third cheapest country for cost of cellular data, right? With so many users and such a huge variety of devices, India is a huge market, right? And with this huge market, there are also like its own quirks and challenges. So yeah, we'll move to how at Dream11 we leverage React Native, right? So historically, like we have been like Dream11 is one of the biggest fantasy sports app in India, and we have like a really large user base. And some about 2 years ago, we decided to move from native to React Native. This was primarily because we also had our sister company, Fancode, who were already on React Native, and we saw all of the benefits that it provided. And theirs was a success story, and it made a lot of things operationally easier for us. We didn't need to hire like an Android and an iOS dev to maintain like two separate platforms. We didn't have to worry about feature parity between both platforms. There were a lot of benefits there, right? So yeah, I'll just kind of give you a brief glimpse into what our app is like. So these screens that you see, they are live on our app as of right now, right? So the first screen is actually our home screen, and then the other two screens are some of the screens that our users interact with a lot. These screens have a lot of information. So the home screen, for example, users constantly come here when they want to see what matches are coming up, what matches they can join, what offers they have. Like all of that information is here on the home screen. Apart from this, the other screens also have like a very graphic heavy, as you can see in the levels page, and also have a lot of animations. For example, when the user receives a reward, we do show an animation that, hey, you've received this reward, and there's like a little animation that plays. So yeah, all of these screens, like performance is very paramount, essentially because users are like, we have a very small window from the user coming in to them actually like joining any contest or like taking any action on the app. So yeah, a vast majority of our screens are, like I said, used daily, and they cater to a total user base of 230 million. And we have around 190,000 plus unique devices. So next we'll jump into how our migration journey looks like. So our migration journey, it was a really mammoth task, primarily because in our migration we already had a native app, and our users were very, very used to it. So yeah, and then we wanted to ensure that, like, for the users, they didn't really notice any difference when they went from like the native app to the React Native app. To give you some context of just how big the migration was, we had around 2,500 pull requests. 200 plus screens were migrated from native to React Native, and we also had 70 plus developers actually working on the entire migration. It was probably like one of the biggest projects that we undertook within the front-end team at Dream11. Cool. So we launched our first version of React Native after roughly like 3 or 4 months of work. This was during the IPL, which is around March 2022. So yeah, I mean, we were like, okay, yeah, we powered through it, and we were kind of like, aiming for like feature completeness and like parity with our native app. And also wanted to like make that experience live for our users, because IPL is like a very big event for us, and even in India in general. So honestly, that really backfired. That was actually a very big failure. We received a lot of user complaints, and we received a lot of feedback that the app has gotten really janky, and like it was frankly unusable, right? We went back to the drawing board after that and looked at like what went wrong, and looked at our entire project and like collected went through all of the user feedback, like put them into like a lot of different buckets, did an entire exercise around that, and from that we basically had 3 main pillars. right? So the first one was app vitals. The second one was testing, because clearly shipping that app and it being a huge failure after investing 3-4 months of like 70 developers' time meant that we had done something wrong. And the third thing was performance. In hindsight, to be honest, all of these seem pretty obvious. But when you're kind of migrating like a very big app and you're like crunched in timelines, there are a lot of these facets that kind of you rely on, and some are gut based, and you just want to get that out there and collect actual user feedback. So yeah, one thing that we realized after looking at all of the feedback is that we were very, very, very ill-equipped, right? Ill-equipped in understanding what our users needed, ill-equipped in understanding like their behavior from our app. So that's something that we had to correct like immediately. Cool. Now, for App Vitals, we actually have a fantastic in-house experimentation platform, which gave us a lot of data, right? We use it to power thousands of experiments across the app, and we used it when we shipped out our React Native app as well. So we went back and looked at all of that data. We leveraged that data to actually give the best possible experience to our users, and we also leveraged it to figure out where kind of we went wrong. So yeah, we were able to figure out some trends in like how users were using our React Native app versus our native app, right? One major trend that we noticed is that for every 100 millisecond increase in startup time, there was a dip in funnel, right? And that dip in funnel directly impacted our revenue, and we were losing quite a bit of revenue because of that. So the first thing that we did was actually revert our entire React Native app back to native, because we do have like feature flags as well, which helped us do that. And yeah, it was not like a little bit of revenue. It was a decent amount of revenue that actually got us worried. Then we dug deep and we found out that a sudden increase in load time between app versions on critical screens that user interact with on a daily basis, they led to revenue loss and drop-offs and a whole lot of stuff, right? And the other thing is to reduce overall crashes and ANRs. So for those of you who have not worked extensively on mobile apps, crashes are when, for example, you tap on something and your app closes instantly. And ANR is essentially an app not responding state, which means that, for example, to render something, it took more than the stipulated amount of time that the OS calculates that needs to render something. And if it goes beyond that threshold, which is, I think, roughly around 5 seconds for Android, the app goes into a hung state. The user cannot really interact with the app. They can't do anything. They have to kill and relaunch and hope for the best. So yeah, since around 95 to 96% of the Indian mobile landscape is Android, which also applied to our user base, we actually adhered to some standards set by Android. So the user perceived crash rate that Google suggests for Android apps is around 1.07%, and the user perceived ANR is 0.46%. This ideally means that the number of crashes that a user gets in a session cannot exceed that threshold, and the number of ANRs that the user gets in that session should not ideally exceed 0.46%. We did a lot of work around this, and these numbers that you see here are what we achieved after the amount of effort that we put in. As of right now, we have around 99.7% crash-free users, which is really, really good, considering that when we did the first migration, this number was a lot lower. And ANR-free users are at 99.8%. So which means that 0.2% of our users face ANRs occasionally in the app, and 0.3% of users actually experience a crash in their day-to-day usage. Cool. So the other pillar that we had was testing, right? Like I said earlier, we were super ill-equipped, right? When we rolled out the V1, we had little to no testing in place, primarily because we were rushing against time. And we actually wanted to kind of get the app out and get user feedback. So essentially, most of our issues were caught post-release. Right? This was very, very problematic. And we had like a lot of user complaints coming in saying that, hey guys, your app does not work. And I mean, they were not so nice about it. But yeah, basically a lot of complaints around the overall usage of the app and the performance of the app. And the load time increase were essentially based on gut. So for example, how much time the home screen takes to load was based on what we felt based on our usage of the app rather than actual data and measurements. So yeah, so we doubled back on it and we actually invested a lot of time in testing. Now, we have around 4,000 plus test cases that cover all of our user flows. The user flows, I mean, for example, say a user wants to sign up, that we have a test case that actually emulates user behavior on like an emulator or a device, right? And it essentially types in the email address, like puts in some OTP, like, goes through the entire flow and then gives us, okay, whether this test was successful or not. Apart from that, because we run 4,000 plus test cases on user flows, most of the issues were caught pre-release. This actually is what kind of is reflected in our crash-free sessions, because earlier a lot of our users faced a lot of issues and we couldn't really catch it before the app went to the user. With the web, one thing is like if there are any issues, you can essentially just deploy your app and yeah, the user refreshes and they will get like the newer version of the app. With mobile, it's not that seamless. Essentially, we still have like users who are on older versions of our application and we constantly need to support it and make it better for them as well. Which is where kind of we also leveraged OTA updates to fix some crashes, which is another really big benefit of React Native. The last thing is, we also instrumented a lot of events across the board, so which meant that we could actually measure load times for every single interaction, every single screen, and like our startup time, and we actually have like comprehensive reports that tell us how all of this kind of are affected in every single version of the app. And we also have tools to kind of compare these two between versions of the app so that we can ensure that there's not a massive degradation. And so yeah, essentially like a lot of data we got out of investing a lot in testing, which helped us better our app overall. So this number is pretty significant, right? Essentially, this is how long it takes to run 4,000 plus end-to-end test cases for both platforms, Android and iOS, right? 1 hour might seem like a lot, but keep in mind that it's 1 hour to actually simulate user actions on an actual device or an emulator. So this, when we kind of started this, it used to take around like 4 or 5 hours on Android and 6+ hours on iOS. We spent a lot of time optimizing this to ensure that we get those reports within 1 hour. Some of the other things that we learned from testing is that investing in a solid testing and reporting framework was very, very good. We got like a lot of data, and the thing is, initially when you're kind of building your app and you have your first version out, testing is generally not at the front of your plan. It's generally somewhere at the end. We figured that while we are developing it, we need to invest a lot in it. And the other benefit that we really got from it was that it completely slashed our on-call and post-release process times. So right now, for example, we get very few issues on call, in production. Even if we do, we have all of the reporting in place to actually understand where this issue is and figure out how to tackle it. The other very, very important thing, like I mentioned, the Indian mobile landscape is a bit different, with the average cost of a phone being around $200, which means that there are a lot of devices with really low memory, and really low processing power. So all of our test cases run on the lowest possible device configuration, right? We did a lot of tests and benchmarks around as you increase the device configuration, your numbers just keep getting better. So yeah, we just run it on the lowest possible configuration because from that it's all gains going up. Cool. While the next thing that we did was look at performance. While looking at performance, we had one very big advantage, is that we had a native app to compare it to. right? If you're starting a new app, you don't really have any like benchmarks for like, what is an acceptable amount of time for a user to register, or what is an acceptable amount of time for a user to complete a purchase. But we had the benefit of comparing it to our native app. And our native app had already been in production for around 5 years. So that gave us like a very, very big boost. We invested in creating a tool that could essentially tell you from the time the user taps on a button, right, to the time that it takes for native to actually draw a text on the other screen. How long does this entire thing take? This takes into account, for example, the time JavaScript takes to process that instruction, send it across the bridge, native to actually receive it, and then render it. So we actually leverage, on Android, we leverage the onDraw method for like the native views and text. So we start recording when the user taps on it, then we end the recording when like, the onDraw method is fired for the native views. So this gives us very, very precise measurements. And the same instrumentation, the tool that we built, runs on both native and React Native. So we got like very, very similar numbers. And we ran the test on native, and that was our like benchmark. So any screen that we were migrating from native to React Native had to meet those benchmarks. Otherwise, we'd kind of relook at it from scratch. So we instrumented a lot of things. Apart from just this, we also instrumented, like, as I said, user clicks. We also instrumented startup time, and we also instrumented the time that it takes to load the screen. So the way that this tool worked is that it just keeps collating all of these like events that happens when the user interacts with the app. And then you can essentially set what your T0 and T1 times are. The difference between these times is how much time it took for like a user to tap on a button and for the next screen to load. One thing that, like a couple of things that we actually realized from using React Native is that large lists are problematic, primarily because to kind of figure out what to show within your viewport, reconcile all of that, and send it over to native, and for native to render it is an issue. So with React Native, if you use, for example, flat list, you will see blanks when you scroll like super fast. So we did face an issue in our chat window because of this. And we essentially kind of, so our chat window is still in native. Because we use React Native, the biggest advantage is you can dip into native at any time. So our chat window is still in native. We had the native component. We could just plug it into React Native. And yeah, that entire component works seamlessly because it used like a recycler view on Android, which is like super performant. The other thing is we actually dug deep and we were looking at what actually needed to be re-rendered. In hindsight, it sounds very, very obvious. Like, but at that time, we were pretty confident that, okay, you know what? Like, we are kind of following as many of the principles of React as we can. So this should not be a problem. But like, if you don't have any kind of standardization or any kind of metric that tells you this, these things are very, very easy to miss. And especially with a larger team, some of these things kind of slip through the cracks and can compound over time. The other thing is, like a lot of micro optimizations, like they might seem like they're not really like, useful, but they kind of lead to a lot of bigger optimization. Even like 100 milliseconds shaved off from like multiple different places can add up to like a second saved overall. And the last thing is defer as many things as possible, like what we do on the web. We also do it on React Native. We load native modules, like we defer loading native modules until you need it. We also have like chunking in place, so it lazily loads like components, screens, only when the user kind of lands on it. And the other thing that we did was introduce the concept of terminal components. Terminal components are basically, these components are sacrosanct. These were the last layer between the JS world and the native world. So essentially, when you're we kind of instill this within our teams that when you're working with these components, be mindful of the props that you pass, right? And be mindful of how many times these components are re-rendered. Right? Once an instruction to redraw a native view has gone on native, there's no way for you to cancel it, right? Because React ends at JavaScript, and then once React has reconciled everything and sent those instructions over the bridge to native, then native does its thing. So you need to minimize how many instructions you send over the bridge to native. The other thing is, yeah, like I said, reduce the frequency of like the instructions sent. Apart from this, when you're building an app for scale and you have like a lot of interactions, composition is very, very, very critical, right? Like we saw in like all of the talks earlier as well, when you want to render like just one part of a really long list, right? Ensuring that only that one part, instructions to update only that one part goes to native is very critical. So we actually split our entire app up. Like earlier, we used to have like, so for example, in the home screen, we have the match card. That entire card was one component. We actually split into a lot of sub-components and optimized every single one of them to ensure that, hey, you don't need to re-render, don't. Like, we'll tell you when to re-render. And in some parts, for example, the timer which ticks like every second, we actually leveraged native to drive it because otherwise React Native was actually sending instructions over the JS thread to native every second, which would block the thread as well. Another facet that we also, so with all of this, we were basically able to eliminate a lot of stuff. And like a lot of the jank, a lot of the slowness, and like actually got very close to native. Another thing that we actually realized is that like, we should benchmark React Native as well, right? Primarily because when we were upgrading, it's possible that like, because React Native has like a lot of like releases and like, sometimes it's not really easy for us to go from say 0.63 to 0.69 or 0.69 to 0.74 and so on, right? We were struggling to kind of catch up with the newer releases of React Native. So what we did is actually benchmark React Native and say that, okay, how much time does React Native in a bare bones app take to actually render like a view or a text? So with this, I would like to introduce React Native benchmarking. Yeah, so we spent a lot of time, like I said, created a lot of in-house tools that actually leverage, like, benchmarking how much time it takes to send instructions from native to React Native and actually render it. So with React Native benchmarking, we are extending this out to everyone. So all of you can actually look at reports for different versions of React Native, compare it between platforms, and also compare between like the bridge mode and the bridgeless mode, right? All of the information regarding like what devices and all of that, the environment is like transparently available for everyone to see, and you can also run your own benchmarks with the tool, with this tool. We're also updating the documentation and providing like more stuff for you to be able to run this a lot more seamlessly. With this, the other thing that I would like to introduce is that we're also kickstarting Dream Sports Labs. We have reaped a lot of benefits of open source, and now we are putting in efforts to give back. We are also actively maintaining a fork of React Native fast image, since the fast image library is like not maintained for a while. We also have developed React Native MQTT, which actually allows you to use the MQTT protocol to like get notifications and stuff like that on your app, and a lot of other things. You can check out the GitHub org. We also have multiple projects in the pipeline, and our developers are contributing to more and more projects daily. And we are also now like actively triaging issues on React Native and like contributing there as well for the growth of React Native. Do check us out, and all feedbacks and contributions are welcome. Thank you.